The seething face of a star. The only star in the universe we can glimpse like this. That star is the Sun. An inferno spewing energy, heat, and light. Without our local star, just 150 million kilometers distant, Earth would be a lifeless planet. The Sun is hub of our solar system. These are its outer limits, a swarm of icy particles stretching a third of the way to the Sun's neighboring star. Like the planets farther in, everything orbits the Sun. Pluto with its tilted orbit, Neptune and Uranus, great spheres of gas. Two more, Saturn with its rings, and mighty Jupiter. Little red Mars and beautiful blue Earth are first of the rocky inner planets, then Venus, and finally scorched Mercury, all captive to the gravitational pull of the Sun. The core of the Sun is a nuclear reactor. At 15 million degrees Celsius, hydrogen is converted into helium in a continuous chain reaction. As nuclei of hydrogen fuse to produce nuclei of helium, there's a tiny loss of mass. That matter is unleashed as energy. Each second, our star loses 4 million tons of mass, energy that will keep the Sun blazing for another 5 billion years. Overall, the Sun is no denser than yogurt. At the white-hot core, however, it's 10 times denser than lead, and energy released there takes at least 100,000 years to reach the surface. That same energy as sunlight takes just 8 minutes 20 seconds to reach us. It powers our planet. Our fossil fuels are stored sunlight. The Sun drives our weather systems, grows our crops, and sustains almost every form of life. By passing a sunbeam through a triangular glass prism, we learn much of the Sun. White light becomes a spectrum of color and dark lines. They reveal the solar composition: 70% hydrogen, 28% helium, and 2% heavier elements, such as iron. Those heavier elements are inherited from a supernova. The death of a giant star, its shockwave interacted with this cloud of gas and dust. As it slowly rotated and flattened, the center collapsed and a nuclear furnace fired up. 5 billion years ago, our Sun was born, and from the surrounding disk, the planets began to form. Our own planet would fit inside the Sun over 1 million times. It's so big, the Sun comprises 99.8% of the solar system. A ball of incandescent gas held together by gravity. This is the solar surface, the yellow photosphere. At 500 kilometers deep, it's the wispy shell of gas that produces sunlight. Real pictures of the photosphere, bubbling granules, each the size of Texas. Gas rises through the granules, cools, and descends again through the separating lanes. Time-lapse of the rotating Sun reveals sunspots. They come and go over several days, and one could swallow Earth. They're cooler than the surrounding photosphere, whose temperature is almost 6,000 degrees. The dark center of a sunspot, the umbra, is just 4,000 degrees. Its warmer periphery, the penumbra, is 5,300 degrees. This comparative coolness is caused by local magnetic fields. Their intensity suppresses currents, bringing hot gases from the convection zone below. Through an 11-year transition, a spotty Sun can become virtually spotless. The cycle is closely linked with the vast magnetic field that swirls and loops through and about the Sun. Every 11 years or so, the field reverses as the magnetic poles flip. 11 years on, it'll happen again. Since the Sun isn't solid, the surface spins at different speeds. The equator rotates once in 25 days. At the poles, it's 34. This tangles and distorts the magnetic field. From maximum solar activity, X-ray images show the cycle through minimum activity, when there are few sunspots, with a return, as the spots increase, to maximum activity. Again, this is solar minimum. And here's solar max. Surface activity in the yellow photosphere orchestrates the show above in the red chromosphere. This inner solar atmosphere erupts with searing gas. A prominence arches into space. Billows of gas sweep along magnetic force lines. Prominences lick hundreds of thousands of kilometers, fueled by magnetic surges beneath. When the Moon covers the Sun at a total eclipse, the corona is visible by naked eye. This rarefied outer atmosphere is far hotter than the chromosphere and photosphere below. And it displays magnificent loops of electrified gas. These satellite pictures show the loops curving round magnetic force lines. They can span 30 times the diameter of Earth. A mysterious energy source at their base heats them to 2 million degrees. But solar flares are the most violent convulsions. A single flare can release the energy of 1 billion megatons of TNT. This is one of the most powerful. Here it is again, erupting near a group of sunspots. It triggers a coronal mass ejection, particles hitting a space probe millions of kilometers away. Twists in the magnetic field are the likely cause of flares and their mass ejections. Between these eruptions, the Sun emits a steady stream of tenuous gas and electrically charged particles, the solar wind. Normally it blows at up to 400 kilometers a second. But at the time of flares and mass ejections, it becomes a storm. We can't see it, but instruments detect it. The Sun throbs in regular 5-minute beats. The cause is sound waves generated by pressure fluctuations deep inside. They provide scientists with an audio picture of the interior. Trapped and bouncing within, the sound waves vibrate the surface in millions of patterns. As with the life it nurtures on Earth, the Sun, like all stars, will die. In 5 billion years' time, hydrogen will run short. The balance of radiation pushing out and gravity pushing in will be gone. The Sun will grow. From a diameter of 1.4 million kilometers, it'll expand to perhaps 200 times that size. Mercury will be consumed. Then Venus. The Sun won't quite reach Earth, but our planet will be a cinder, devoid of oceans and life. Puffing off shells of gas, with hydrogen and helium spent in the core, the Sun will become a red giant. Finally, its outer layers stripped and its core exposed, the Sun will collapse to the size of Earth, a white dwarf. As it cools and dims to become a black dwarf, our solar system will be left cold, dark, and dead.